Okay, today we'll look at chemical reactions. So we're going to learn to recognize the chemical change or physical change and be able to differentiate between the two. So like a burning match, chemical change or physical change. Think about that for a second. And one of the first key points is what always happens during a chemical change. Now, when we want to describe a chemical change, we will use words such as burn, rot, rust, decompose, ferment, explode, corrode. Any words like that usually tell us chemical change. The ability of a substance to undergo a specific chemical change is, of course, called a chemical property. So iron combines with oxygen to form rust. The ability to rust is a chemical property, then, of iron. Chemical properties can be used to identify, but chemical properties can only be observed when a substance undergoes a chemical change, which means it changes the substance, right? So, for example, when charcoal is broken down into smaller pieces, the change is a physical change. It's still charcoal. So, it's just the only difference is the pieces are smaller. During a physical change, the composition never changes, still charcoal. Key point though, during a chemical change, the composition of matter always changes, so we get something brand new. So when we heat the charcoal or burn it, a chemical change occurs. The substances in charcoal react with oxygen and the heat to form other substances, so we get something brand new. A chemical change is also called a chemical reaction, and it's where one or more substances change into one or more new substances. So a chemical reaction and a chemical change are two of the same thing. What we have at the start of a chemical reaction is called a reactant. What we get at the end, or what is produced, is called a product. When we burn charcoal, carbon and oxygen are the main reactants. The main product is CO2, carbon dioxide. So we have reactants and products even in the burning of charcoal. What is always true of a chemical change that is never true of a physical change? Think about it. During a chemical change, the composition of matter always changes, so you get something brand new. During a physical change, it's still the same substance, just looks different. Key point, what are 4 possible clues that a chemical change has taken place? Possible clues are a transfer of energy, gets hot or gets cold, a change in color, the production of a gas, where if it's a liquid, we'd see bubbles, or the formation of a precipitate, which is a solid that forms when we mix two liquids. Every energy change, or every chemical change, involves a transfer of energy. So let's say we have a gas stove and we want to use the energy stored in natural gas to cook food. That methane comes up, mixes with the oxygen, we light it on fire, and we get energy. And then that energy then is absorbed by the food when it cooks. So therefore the energy is transferred. The cooking of food is a chemical change. The food may change color. We see that for sure, right? And that's another clue. You can observe 2 other clues of chemical change when you clean a bathtub. You have soap scum that can form in the bathtub. That's an example of a precipitate. After you bathe, take a shower, take a bath, the soap scum will form on the bathtub. So a precipitate is a solid that forms and settles out of a liquid mixture. And again, you'll see that a lot when you have 2 conceivable liquids mix and you get a solid that forms. Now, some bathroom cleaners remove soap scum and start to bubble when you spray them, okay? When those bubbles are produced, that is a gas being released, and that tells us that a chemical change is taking place. So if we have a gas or see bubbles. If you observe a clue to chemical change, you cannot be certain that a chemical change has taken place. That's just an observation you make. The clue may be the result of a physical change. So like boiling of water will give you bubbles, even though it's still water, okay? And there it is. Or if you open a carbonated drink, right? You open up a pop, and the bubbles that form, it's not a chemical change. So bubbles, it's a clue, but it could be a physical change. You have to always gather as much information as possible before you make your prediction. The only way to be sure is to know if you get something brand new, right? So you test the composition before and after the change, and if it's something brand new, then it is a chemical change. So some practical applications: production of a gas. Let's say you had chili for dinner and your belly hurts and you want to take some antacids. When you drop 2 antacid tablets in a glass of water and the bubbles that you see, plop, plop, fizz, fizz, those bubbles of carbon dioxide are when the chemical change is happening. You may have used litmus paper at some point. When that test strip is dipped into a solution, the color change, that tells us there's a pH, the pH of the solution. That is a definite chemical change. A precipitate, when you make cheese, when milk separates into solid curds. So when you can take your liquid milk and it starts to separate into curds and whey, that is the formation of a precipitate. Now, are the changes that happen to a burning match chemical or physical changes? How do you know? Think about it. A burning match is a chemical change. And that's because, one, it gets hot, so we got a transfer of energy. We see light, and we see a change in color. Plus, that match turns into ash, which is a change in the composition. Therefore, you know for sure it is a chemical change. How can you determine for sure that a chemical change is taking place? Think about it. The only way to determine for sure if a chemical change has taken place is to test. You have to make sure that the sample is different afterwards than it was before. Now, conservation of mass. How are the mass of the reactants and the mass of the products of a chemical reaction related? When wood burns, substances in the wood combine with oxygen from the air. So when you burn wood, you see ash, right? You see smoke, but you see a definite change, right? And what you seem to think is that the wood is disappearing, but that's not what's going on, right? Appearances can be deceiving. Because during chemical reaction, the mass of the products is always equal to the mass of the reactants. So 2 of the products, burning wood, carbon dioxide gas, and water vapor, are released into the air. So when the carbon dioxide and water release, we're losing mass with our wood. So when the mass of these cases is considered, the amount of matter is also unchanged. So if we were to collect the carbon dioxide and water vapor that come off of burning wood, we would see that the masses then would equal the mass, the mass of the gases plus the mass of the ash would equal the total mass of the reactants, which would have been the wood. Mass also holds constant during a physical change. If we melt 10 grams of ice, we will get 10 grams of liquid water. And that's a little more easy to see because you're not changing the substance. But in chemical changes, with the substance changing, sometimes that's difficult to imagine. The scientific law that shows these observations is the law of conservation of mass. And by definition, it is a physical change or chemical reaction, mass is conserved. And that's always true. It's neither created nor destroyed is another way that it is worded. So we can see this in a closed container. So we have 2 liquids to the left, and they have a mass of 43.43 grams. We mix them, a reaction happens, we get a different color liquid, so therefore we assume that there's a chemical reaction. But we see the mass hasn't changed, it's still 43.43. To what changes does the law of conservation of mass apply? Both chemical and physical changes. And that is it. If you have any questions, please see me.